Hello and welcome to PetXI Interactive, the home of GCSE revision on the go. Have you ever stepped on some weighing scales and thought, I used to weigh less than this? Or, I've clearly eaten more than my fair share of pies this week? Well, when dealing with things like less than and more than, we use some symbols to speed things up. Us maths people are proper lazy sometimes, aren't we? We use these special symbols when we are dealing with questions to do with something called inequalities. So, in this maths burst, we shall be looking at questions involving inequalities. I am in fact so confident about how easy this maths is to teach that I'm going to show you in a race against Dave, who has bet me that he can complete a challenge before I can get this maths across to you.
The challenge is simple: to get these 30 trackers to the animals before they can get lost or before you can finish the maths.
Well, make sure you don't get eaten. Now, before we start looking at some of the questions, let's have a look at the different inequality symbols that are used. Now this is like an arrow pointing to the left. Left sounds a lot like less, doesn't it? Which is handy, as this symbol stands for the words is less than. If the arrow is pointing to the right, this is the opposite direction, so it means the opposite of less. The opposite of less is more. Therefore, this symbol stands for the words is more than. Now, if we have one like this, it looks a lot like the less than symbol, but it has an extra little line underneath. If you see this line, the symbol means is less than or equal to. And in the same way, this symbol stands for is more than or equal to. So make sure you look at the symbols carefully in the questions. Let's have a go at representing some inequalities on a number line. For example, x is more than 3. If we think about what this stands for in words, it will read x is more than 3. So, x could be 4 or 5 or 6 and so on, all the way up to a billion squillion. We can represent this in the following way using circles and lines. First, we draw a circle above the 3 on the number line. At this point, we could choose to leave the circle as just an outline or fill it in. Our choice depends on the symbol that is being used in the inequality. In this case, it's the is more than symbol. If we see this symbol, or the is less than symbol, we leave the circle as an outline. X could be 4 or 5 or 6 and so on, which are all to the right of the circle. So we finish our diagram by drawing an arrow to the right. Okay, let's take it up a notch. Let's have a go at representing the inequality -1 is less than x, which is less than or equal to 4. Let's start off by drawing the circles above the -1 and the 4. The symbol next to the -1 is a less than symbol, which means the circle does not need filling in. But the symbol next to the 4 is a less than or equal to symbol, which means the circle does need filling in. So this time it's different. We have two circles, so we can just connect these with a line. That wasn't too bad, was it? Now, sometimes you may get a question like this. Write down all the possible integer values of x when -1 is less than x, which is less than or equal to 4. An important thing to remember is that integer means whole number. Why mathematicians need to use such fancy words when it's something as simple as that is beyond me. But getting back to the question, let's look at the first part. -1 is less than x. So -1 is less than x. This means that our x has to be more than -1. So our list of possible values has to start with 0. But how many numbers will x go up to? If we look at the second part, we can see that x is less than or equal to 4. So x can go up to 4. The values that x can be are 0, 1, 2, 3 or 4. This is our answer. So, let's go and have a look at how the challenge is getting on.
Well, Tom, the animals are trying their best to get away, but we are starting to get the trackers to stick to them.
I best get a wriggle on. One last bit to inequalities is how to solve them. Now, for this, we are going to use that magical method of ours again. Can you remember it? Hopefully, you were thinking of float and ping. If not, then it will be worthwhile watching our video on solving equations, as the method is explained in there. So just like when solving equations, we need to get x on its own. To do this, we can use the float and ping method. Let's have a look at an example. 2x plus 2 is more than 16. Now, don't worry about the inequality symbol in the middle. Just make sure you don't change it to an equal sign. Do this and you will be throwing marks in the bin. Now, first we need to float across the +2. We circle this and float it over to the other side. Once it makes it to the other side, it pings to a -2. 2x is more than 16 minus 2, which becomes 2x is more than 14. This 2x here means 2 times x, but we just want x on its own. We need to float this 2 over as well, but when this floats over, it pings from times by 2 to divide by 2. So we get x is more than 14 divided by 2, which then gives us x is more than 7. Now, x is on its own, and at no point did I change that inequality symbol. Sometimes you may get a problem with brackets or with an x on both sides. Just use the same approaches we used when solving an equation, but never change that symbol to an equal sign. Let's see how Dave and his team of tracker ninjas are getting on.
Well, it was going amazing, but it seems like the animals have managed to make a break for it.
So there we have it, another victory for the mathematicians. So yet another fantastic use of float and ping. I told you it was good. Thanks for watching, and see you again soon on another exciting instalment of PetXI Interactive Maths.